Hello YouTube, this is Eli, the OBD Tech. I'm here working on a 2002 Nissan Sentra with the 1.8 liter engine. The complaint on this vehicle is that it has a low idle symptom, especially when it comes to a stop. It tends to run rough and idle real low. So on this diagnosis, I'm going to concentrate on the throttle position sensor, maybe a dirty throttle body, or perhaps a faulty or dirty idle air control valve. So like I said, so this diagnosis, just on the symptoms that I'm hearing, I will perform this checks on those two components and also do a visual inspection on the throttle body. But before I do those tests, I will first do a diagnosis on the scan tool to check those parameters on those two items, the idle air control valve and the throttle position sensor. And then I will also show you guys the wiring diagram on both components to see how the computer does the control on these sensors. Even if this diagnosis is not a successful diagnosis, the thing that I want you to get out of this diagnosis is how to check those two components that I will check. Like I said, the throttle position sensor and the idle air control valve. On this Nissan, it is a 6-wire stepper idle air control valve. All right, guys. So the next thing, I guess the next step is to show you guys the live data with the engine during idle. All right, guys. So I already have my scan tool set up with the parameters that I have chosen that basically relate to to the idle air speed, which is a coolant temperature sensor. Right now it's at at 70 degrees, which is close to 158 degrees Fahrenheit. And also I'm also showing the the idle air control valve. It's currently showing 33%. Like I said, this valve is a stepper IACV. And I'm also showing the throttle position sensor voltage, which is showing currently at idle 0.054, and also the percentage on the throttle body, which is showing 0%. And last but not least, the engine speed, which is currently showing about 825 RPM. Now I'm going to show you guys the specs for this vehicle. For this vehicle, during like for example, the idle speed for this vehicle, with the engine running either on park or neutral, it should be within 800 plus or minus 50 RPM, which is showing right now about 125, which is basically within spec. The other spec that I'm going to show you is the throttle valve fully closed. After warm up, idle the engine, it should be between 0.015 and 0.085. Currently is showing 0.54 volts, which is within spec. And then the idle percentage, the TPS percentage during idle with the fully closed throttle valve, it should be about 0%. And with the engine warm up at idle, it's currently showing about 0%, which is also showing within spec. And then our ISC parameters, sorry for the glare, guys, it's just it's a sunny day. The idle ISC steps should be between 5 and 20 steps. Currently our ISC percentage is showing about 31 degrees. It's already at 84 degrees, which is close to, it's a little bit above 176 degrees Fahrenheit. So in other words, since the vehicle is already warmed up to almost to its normal range, this ISC supposedly at idle should be within between 5 and 20 steps. At 2000 RPM, it doesn't really show any value. I guess it's gonna vary, but I'm probably suspecting just by looking at the the ISC valve percentage at idle with the fully warmed up engine being at 31 degrees. I'm suspecting probably a dirty idle air control valve. So in other words, what I'm seeing is that the computer is trying to compensate maybe for a sticking idle air control valve. So so it's commanding the ISC valve to remain more open. Well, since it's at 31 degrees, and like I said, the specs shows between 5 and 20. So I'm gonna rev the engine and see how the percentage acts on the ISC valve. As I raise the engine, the percentage goes higher. Our absolute throttle position sensor percentage went up. Our throttle position sensor voltage also went up. I'm gonna drop it back down. So right now our RPM needle is still within spec, but watch when I put the vehicle in drive. See how those RPMs basically drops below spec. You see how the idles really went very low. Now let me show you back on the scan tool. It's currently showing about an average of 600 RPM, which to me that's very low. Our ISC command is about 27 degrees. Now, right now, the selector is in D drive. Now, I'm gonna put it in neutral, and let's watch our RPM jump back to normal. So our RPM went back to its to spec. Like I said, it's between 800 plus or minus 50. Our ISC command went back to 30. Our throttle position sensor, it never really changed. It was maintained at 0.54, which is still within spec, which is good. So right now, I don't think it's probably a problem on the throttle position sensor. Maybe a dirty throttle body, or a dirty idle air control valve, or perhaps maybe a faulty IAC valve. But I will still show you guys, how to test the TPS on this Nissan. All right, before I begin with the component testing, I'm gonna write down these values and then compare them after doing our diagnosis. All right, guys. So next step is to basically do some voltage checks on the throttle position sensor, and after we do our checks on that component, we'll go to the idle air control valve. All right, guys. So I'm gonna start with the throttle position sensor on this Nissan's. There's always two connectors on the throttle position sensor. The connector that's brown, that's your your throttle position sensor connector. It has 3 wires. The first wire is a black one, and that's gonna be your ground wire. So the first test I'm gonna do is do the voltage test, the voltage check on the ground wire. So I have already back probed the black wire, which is the top one. It's currently showing 0.05. Specs on the ground wire should be it should be less than 0.1 or less than 100 millivolts. So the best thing to do is to do with the loaded circuit. So I will open the throttle body to see if our ground is glitching or something. So here you go, guys. This is with the throttle body open. So our ground is still good, with the loaded circuit. So next wire I'm going to back probe is the feed wire. I believe, I'm not sure if this is going to be a 5 volt or 12 volt or a 12 volt voltage source. which is the red wire. That wire is the one, basically it's the bottom wire on this brown connector. It's red. So I'm gonna back probe it. So that should give us either 5 or 12 volts. I'm pretty sure on a TPS sensor it should be a 5 volt voltage source. And as you can see, we have 5.18, which is within spec. So like I said, the best thing to do is check it with the loaded circuits. So I'm gonna open up the throttle body wide open. So as you can see, with the loaded circuit, our voltage is not dropping, so that's good. It remains at 5.18. Then now the next step is to check the signal wire, which is the yellow wire. It's the wire on the middle of this connector. I'm gonna back probe this. This yellow wire right here. Remember the specs for this vehicle should be with the throttle body fully closed, should be anywhere from 0.15 and 0.85. So I will perform it's called a sweep test, currently showing 0.77, which is also within spec. We saw that with the engine idling, it dropped to 0.54, which is still within spec. But with the engine off, with the key on engine off, it's currently showing 0.77. Now I'm going to show you guys with the lap scope instead, and I will perform a test called a sweep test. I will open the throttle body slowly, and let's watch to see if there's any glitches or any drops on the signal wire. So here we go, guys. So our goal is that this graph, this signal increases smooth with no glitches or drops. So here we go. So I'm currently opening the throttle body slowly at wide open throttle. The spec at wide open throttle should be, I believe that's 4.75. Currently showing 4.16, still within spec. I'm gonna drop it back down. I will change, I guess I'm set at the wrong voltage. I'm gonna drop it to 10. I will perform this test one more time, and let's watch our signal. I'm gonna open the throttle body slowly. As you can see, I don't see no glitches. This is wide open throttle right now. I'm gonna release it. A sweep test should be done like that, nice and slow, and just watch your signal to see if there's any glitches. So now the next test, I'm gonna do a throttle snap to see if there's any potential glitches by snapping the throttle body quick. So let's do this. So I'm gonna just snap it real quick to see if there's any glitches with the quick snap. So here you go, guys. You can see that's good. I snap it again, and that's a good normal waveform. That should be the waveform for a quick snap. So currently, I don't see no glitches. So I'll say that the TPS sensor is not the culprit fault of this low idle complaint. I'm going to perform one more time. You can see that's a good waveform on this TPS. Alright guys, so I guess the next step I'm going to show you guys is the IAC valve voltage checks. Alright guys. Alright, so before I begin with the checks on with the lap scope, I'm going to give you a brief history on this Nissan's 6-wire stepper motor IAC valve. These are ground side switch. There's 4 control wires and 2 feed voltage wires, like the middle ones. I believe they're the 2 middle wires, which are pins 2 and 5. There are green with white. Those are your 12 volt feed. They come from a 15 amp fuse, I believe. And then your your top row wires, which is our pins 1 to 3. Your pins 1 and 3 are your control wires. Like I said, these are ground side switch. And on your bottom 4 wires, I believe they're a light green and orange wire. Those are your bottom 2 control wires. And your middle one, like I said, that's a 12 volt feed, which comes from a 15 amp fuse. So like I said, there's a ground side switch. You should have 4 control wires and 2 voltage feed wires. Alright, so the next thing is to do the voltage checks. I will perform these checks with key on, engine off, and let's watch our first. I'm going to back probe the first 2 control wires, which is pins 1 and 3, and let's watch our waveforms. Alright guys, so to perform this test, we must cycle the key on several times. This is basically what's happening, that the computer is activating the IAC valve momentarily. So we should see a control wires activation on this IAC on pins 1 and 3. So if we see this waveform on channel 1 and channel 2, it means that the computer is commanding the IAC valve. So here we go, guys. So this is with the key on, engine off. I'm gonna cycle it on and off, several times, and let's watch our waveforms. So you can see the computer, it cycled the IC valve momentarily. I'm gonna turn it off. You can see it cycled it again. I'm gonna do it again one more time. There you go. The computer activated those pins 1 and 3. Remember, let's not forget this is a ground side switch. I turned it off again. This key off, key on, engine off again. Turned it off. So it means pins 1 and 3 on those 2 control wires, it shows that there is control. I don't see no glitches. So now I'm gonna back probe pins 4 and 6 on the bottom 3 wires. Alright guys. So now I'm back probing pins 4 and 6 on this connector. Pins 4 and 6 are gonna be a light green wire, and the other bar is gonna be an orange wire. So like I said, this is pins 4 and 6. So I'm gonna connect the connector and then show you guys the the waveforms. Alright guys, so I'm back probing pins 4 and 6 now. I'm gonna perform the same test. I'm gonna cycle the key on and off, and let's watch the waveforms on channel 1 and channel 2. Here we go. Key on. As you can see, the computer activated the control wires momentarily. Turn it off. Alright, I'm gonna turn it on back. I'm gonna turn back the key on again. So that's good. So this shows that all 4 control wires are good. And the last test is to just check, just to verify that our voltage feed on those 2 wires on the green with white have that both have the voltage source, which is going to be 12 volts on both wires. I'm going to turn it off. You can see, I don't see no glitches. That means the computer and the IC valve is good internally. Back on again. Alright guys, so next step is just to verify that we have 2 good voltage feeds on pins 2 and 4. No, 2 and 5. Alright guys. Alright, so I already have a back probe pin 2, which is a green with white wire. Green with white wire. It's showing approximately 12 volts, which is good. Now I'm gonna back probe pin number 5, and let's watch this 12 volt source from that pin 5 too. Alright, so this is pin number 5. It is also showing 12.15 battery voltage, which is coming from that 15 amp fuse. So this basically is the way to check both the TPS and the IAC valve on this Nissan. Basically, any Nissan that has this type of setup, a 6-wire stepper IAC valve and a TPS sensor that has two connectors. One is brown, which is right here, and the other one's black. It's gray, a gray connector. So two connectors on the TPS. So that's how you check the TPS sensor on a Nissan that has, this type of TPS sensor. Two connectors, a brown and a gray. So I guess the next thing is to oh, by the way, since we could look at the throttle body, it looks pretty clean. So I wouldn't say that it's a problem with the dirty throttle body. So I guess the next thing is to do a visual inspection on the IAC valve, which lives right here. So I will remove it and do a visual inspection, guys. All right, guys. So this is the IAC valve already removed. It does seem to have some carbon buildup on the pintle. So I guess what I'm gonna do is basically clean it, with either brake cleaner or with the throttle body cleaner, and then put it back and see if by cleaning it, it does improve the idle. All right, guys. So this is moment of truth. This is after cleaning the IAC valve. Our IAC valve is at 29% currently, but it's dropping. Our throttle position sensor voltage is at 0.54. That's still the same. Our percentage on the throttle body is 0%, which is the same. Our engine speed, it's also the same as before cleaning the IAC. But one thing I do notice is the IAC valve is dropping to 22% as the engine warms up. It seems that it's dropping. It dropped to 21, so it's basically on the specs for this vehicle. The IAC during idle should be between 5 and 20 steps. Before cleaning the IAC, we were at 30 steps, and then after putting the drive selector to D, the IACs would drop to 27. Currently, our IAC is still at 21 degrees open. So it seems that by cleaning the IAC, it did help. I wouldn't say that it's totally a fix, but it did improve. Now the next step is to put the drive selector on D and see how much the IAC drops. So there you go. Right now it's currently at 17 degrees. Like I said before, it was at 27 steps after putting the selector on D. So this is a 10 degrees difference. I'm going to put it back to neutral. Our IAC currently is at 20%, which is within, right now it's showing that it is within spec, between 5 to 20 steps. So I'll say for now this is an improvement, not a fix. I'll wait until the customer drives the vehicle and see if the symptom stays the same. If the symptom doesn't improve, it means that this vehicle has another problem. Maybe I would have to attack maybe the fuel trims. Maybe it has a problem with the maybe a MAF sensor or a fuel delivery. Maybe something else besides this the idle valve being partially dirty with carbon buildup. So I'll say for now this is an improvement. I wouldn't say a fix, but we'll see as the customer drives the vehicle, and I'll keep you updated. So maybe there might be a part 2 potentially. So thanks for watching. Subscribe if you like. All right, this is Eli the OBD Tech.